make it taller. Let me make it taller.
Okay, pass to the front. No one person help me pull it.
Is it better if I put it here? Wait, I think it's better. Wait.
That looks extremely dangerous and I do not recommend doing that.
Done.
That's all I survived.
Later, the iPad fell down and Mr. Jeffrey walks over.
That's extremely precarious and I do not trust it.
You want some money? Okay.
Anyone just walk running past the
Yeah. Okay. Zed, can you help me just quickly take note? Who is submitting on Monday? Just raise your hand. Okay, Zed, can you help me take note? We know the names,
Do you remember who the name
No, I mean you can remember. So Monday you must collect from here. Okay, raise again. So Zed knows who to collect from. Oh, your memory is insane. Okay, today, can you take out your practical worksheet? We're going to complete a discussion. Yeah, we'll discuss it together. I asked you to write. I asked you to complete all the pages. You complete your page 2, page 3. Yeah? Yes?
This way.
See? Oh, I understand. Okay, great. Okay, we're going to have a quick discussion of your worksheet before we continue on the lesson. Yes? Oh, you're also not around, huh? Yeah, no one here kept for friends when you answered? Okay, unfortunately I don't have a spare. I double check, no one kept for your friends. That day I remember someone kept extra. You? Oh, so you passed the extra here, the practical, but you don't know where it went. Okay. Okay, then I need to get a new one for you. Today I need to share. Okay, yeah. Yes. Okay, then. What am I going to run with you? Contrary to popular belief, I'm not. Yeah. I just somehow don't put on fans, Okay, so let's have a quick discussion. We did the stopwatch activity on page 1 together. Yeah. Right, okay, so let's go to page 2. I know you collected a lot of data, but let's have a discussion on your collection. Okay, first question I have for you. What measuring instrument do you use to measure mass that day? Okay, thank you. It's great. I love it that you are answering together. Okay? You know I have to give up one of the classes eventually, right? Either 105 or 106. I need to return one of y'all to Mr. Lim. You know? Remember? Yeah. So I will decide which one I'm going to return. Okay. So, what was I talking about? Okay, mass balance.
We'll go on a
Still got Ozone, there.
Which is the class with Samuel inside?
105.
No, I want the class with Samuel. Very bad, Samuel, what kind of now you expect? Okay.
I know I look goofy as well.
No, I was going to say look very smart. Okay. Okay, mass balance we use to measure mass. Okay, I would like to ask you, when you measure the mass, right, how many decimal places? Okay, come, yes. 2, 3. Okay. You want to 3 or 4? 3. Okay. What was the unit? Grams.
That's why we didn't use it to measure.
Okay, for everything you measure, you will always have the numerical value, and you will also have the unit. Good question. Will it always be 3 decimal places? Not always. It depends on what balance I give you. Okay, we do have some that goes up to 4, some only up to 2. So what is the point I'm trying to make here? Whatever value they give you, to whatever decimal place, you must write everything down. Even if, just nice, you measure this. Okay, there is a chance that you may end up measuring something like that during a practical exam. If you measure something like 1.200 grams. Oh no, it's just that some students will write down in their practical exam worksheet, you know what they write down? You end up writing 1.2 grams. And then, right, the teacher will mark you wrong. Even if you were actually measuring it correctly, because you missed out 2 zeros. You must write down the same number of decimal places as the instrument you use to measure. Yes?
So like, you know the mass balance we use is like really sensitive. So if we get something like 2.00357, do we need to write all of it?
Why was there a dot dot dot?
Like because there are all the
Yeah, the mass balance only go up to 3 decimal places, right? So how do you get more? Okay. Oh, but there is this problem, that they fluctuate, right? So fluctuate how? Right? Okay. So usually for teachers, we will have a range of answers that we will see whether you fall within that range. So that we have a lower limit and an upper limit. We do account for the fluctuation. So if you, as long as you get the correct decimal place, right, it should be okay. Yes, then?
What if it's so light it shows 0?
Okay, why if it's so light it shows 0? I mean, I won't do that if I want to test you during a practical exam. I will purposely choose something that you can measure. And I will measure it to make sure it is measurable. It's in term 3. Yeah, wow. No, we have no practical exam. Okay, you look at the textbook. Yeah. Garrett, where is the page? Page 6. Okay, look at page 6, you can see all the dates. So, sorry, your practical test is term 2, week 3. Term 2 is after March holidays. Yeah. Okay, what will be the topics tested? It will be all the things that you can measure. Okay? So, for example, the lesson we just had, right? You use the vernier caliper, the micrometer, screw gauge, you use ruler, right? Mass balance. During the practical, expect that you will be using all these instruments again.
Wait, so they give one instrument for
I will try to. Yeah. Okay. Hold on. I complete my answers first. Okay. The next lesson, the next practical, I will give you another opportunity to practice these instruments again. Okay. That may be the last time you get to practice, so use that time wisely. Okay. Yes.
So is it only practical for term 2?
No. So you see term 2 on page 6, term 2 week 3 you have a practical test, term 2 week 8 you have your very first quiz. Yes. Practical test is hands-on. Your quiz is you will sit in the classroom and then you will be given papers and then you will do your questions there. Okay? Yes. Yeah, you look very shocked. Yeah, practical test will be in science lab. Okay, so what are we doing now? Okay, so why am I bringing this up? You all take note of this. You must write it to the correct decimal place. The word I'm going to teach you now, the word is precision. Every measuring instrument has their own precision. You must write it to the correct precision. If you write missing a decimal place or too many decimal places when the precision is supposed to be up to 3, we will not give you the mark, even though you got the numbers correct. Why is this so? Because if a scientist from another part of the world, they know that you use this brand of mass balance and they know that you'll go up to 3 decimal places, and then you show them that your value that you measured using this instrument is 1.2, they will start to question, then what was the other 2 decimal places? Here and here. Right? If they know that the instrument can measure up to 3 decimal places, but you only show them 1.2, actually the scientists in another part of the world will be very confused. They'll be asking themselves, do you leave these 2 values out? Or was it 0, 0? Or was it 0, 1? You don't know. So you must write down the correct precision. So for your example, the mass balance, it was 3 decimal places. What about the instrument you use to measure? What's the next instrument you use? Okay, ruler. Let's talk about your ruler. You used it to measure length. But what was the decimal place it was? 1 decimal place. And what was the unit? cm. Okay. The next instrument you used to measure length was I'm going to write down the digital, thank you, caliper. And you used it to measure length too. What decimal place did you go up to? 2 or 3?
3.
I think go to 3 or 2. Let me look at the reading. Sure it's 3? I don't recall it's 3. What was the unit? Millimeter. I think it was 2. I don't think it was 3.
Oh, your foot.
Wait, did anyone get 1 decimal place? You got 1 decimal place for your vernier caliper? 1 decimal? Okay, then I think it's 1.
No, but then I wrote 1 decimal for everything except for the digital micrometer screw block.
Okay. I cannot remember now digitally what it was on the scale. Okay, but what's the point to make sure? Again, just write all the decimal place when you get the instrument. Okay? Even if it's a 0 at the end, just write it. Okay? The screw gauge. Yeah? Oh, for the micrometer screw gauge, do you go up to 3 decimal places? And then it was mm. Okay. Okay. Will these number of decimal places change? It really depends on what model we provide you. Okay? So whatever model we provide you, just make sure you don't leave out any zeros. And the word I'm using here again is precision. Every measuring instrument has their own precision. Some have higher precision, some have lower. If you compare between the ruler, the digital caliper, and the screw gauge, which one has the highest precision? Okay, so you notice I would say something has a high precision if it has many decimal places. Something has a low precision if it has a few decimal places. to copy something, you just give yourself a reminder on the red part about the precision. Don't forget the decimal places. Okay? I think next week. No, you won't. So we expect you to know that digital caliper from now on is just measure length. Yes, we will tell you to use it. Yeah. Yeah. So we will not tell you to like up to you which one you want to use. We will tell you now please use the micrometer screw gauge to measure this. So it's very explicit. We will tell you. So what's the skill? Really, you just must read correctly and write correctly. Yeah. Oh no. You all not be sitting at a circle table. For a practical exam, we will bring you to the very legit labs where your seniors all use. You'll be seated in rows. Then, really? Oh no, each table you only put like 2 to 3 people and then you'll be spaced out.
Then you have 2 to 3. Then
But I trust you all have honesty. Oh, okay. I'm not advocating for you to cheat, but yeah, is right. During a practical exam, you sort of can see what everybody is using, right, at that point in time. Yeah. Okay, I'm not teaching you bad thing, Hey, but I've seen before, everybody do the wrong thing. Because they all see each other. Very amazing, right? Yeah. Yeah, you know, last time chemistry, I saw this very funny one. They teach them many different experiments. One of the experiments requires you to test for gas, right? So there's one experiment to test for gas where you need to light up Bunsen burner. Then you won't learn yet, you learn next time. And then you put a stick in and then you hear a pop sound. But that particular practical exam did not require you to do that at all. But one student decided that he will do the test for gas and then he made a pop sound. Next thing we knew, we started hearing pops everywhere. Because they all felt scared that they were doing the wrong thing. So doesn't mean your friend do means they're correct, Okay. Next thing I would like to talk about would be the similarities and differences between the measuring instruments. Okay? No right and wrong answers here. Really just want you to be a little bit observant. So, between the ruler, caliper, as well as the screw gauge, what similarities do you observe? Okay, why I do that? Why you erase away? Okay, ruler.
Ruler's like 90 cents. Expensive lah. Yeah.
90 cents for plastic.
They are all made of products.
Okay, may I share your views? What are the similarities?
They have metal.
Do they all have metal?
Ruler's
Not exactly, Okay, yes? Okay, they're all for measuring what?
length.
Length. They're all for measuring length. Regardless of the instrument you're using, they're all to measure length. Any other similarities? Yes. You cost money to raise also. Yes. Oh, okay. Listen up. May I ask, isn't the micrometer screw gauge used to measure weight? Okay, actually, if you think about it, width, height, depth, breadth, they are all length, right? Okay? Always slam, Okay, any other similarities between your instruments? That's about it, right? They all measure length. Okay, what about the differences? What are some differences you observe between all the instruments? Yes. Okay, different levels of precision. Any more, Xavier? Okay, the method is different too, right? Ruler, you just press it against the whatever you want to measure, you take a few measurements. Yes, Isaac?
Some is digital, some is you have to do it manually.
Okay, wow, this is a very new point. Although it's obvious, but we did not, a lot of classes didn't mention it. Some are digital, some are not. Okay, these two are digital in nature. This one is manual one. Yes?
What if you have to measure like very long distances?
Oh.
Like kilometer.
Okay. Are you asking during a practical test? Or are you asking in real life, what do we use to measure a very long distance? Okay, so that's a good question. How do we measure things very long distances in real life? Do we use one ruler and then you just keep like, yeah? Have you seen measuring tape? That's one way you can measure slightly longer distances. But what if you're looking at distances that go to the kilometers? I do know that people now have a tool that looks like a gun. What it does is that it shoots a laser to a distance far away, and then gun will be able to measure the distance to where the laser is. Sorry? Okay. Okay, here shared that is property agent, so she uses something like that. What? Oh, it's a meter version, but it's used lasers also. Okay. Yes? Oh, okay. So, has anyone encountered the wheel method of measuring? Okay, let me show you. See before? Do you know the PE department has this? Yeah. Yeah. I've seen our PE teachers use this on the track before. They measure. Only you. That's why you got measuring tape, huh? Okay, so that's another way you can measure things. Yeah? How long does that go? How long does that go? Wow. Looks like meter, right? Okay, looks like meter. Okay. There's some differences in precision, digital nature, and really times have changed. Do you know, you are very lucky, just one batch before you, they were using calipers and screw gauges that were not digital. They were manually reading after they ship the thing. After they ship the thing, you know, oh no, after they ship the thing, you notice that the caliper and screw gauge, they actually have units? Yeah. Your seniors actually need to learn how to read the units. And it's not easy. You know, last time when I teach how to use this, I'll spend at least 2 more lessons teaching them how to read it. But then for you, you just need to know how to copy the thing down. Oh, it looks exactly the same. Let me show you. Yes, what? Yeah, so your seniors use this. Notice theirs does not come with a digital part. Yeah? Screw gauge looks like that. This is what your seniors use, yeah? What's the difference? Yeah. Oh, I spell wrong here. Your seniors one comes with, yours come with additional screen, right? Yeah. So you're very lucky, times have changed. This is really the nature of science. When we improve, technology allows us to do things easier. We are not going to still make you do this, right? Do you know that your seniors are no longer plotting graphs by hand? Instead, we are teaching them how to use software, Excel, to plot graphs for their practical. And that's what they'll do for their practical exam next time. So next time, yeah, eventually. So you notice a lot of things they used to do by hand, you will now do digitally. So that you can focus instead on the tougher things. You all use abacus before?
Oh yeah, I use abacus.
What is abacus?
I use it. I still use it. I use one. My friend doesn't say mentally. Oh, I thought it was a music. Oh, I do before.
Okay, who has used this before? When do you learn it? Kindergarten, right? Yeah, I tell you I learned this in primary school. During my primary school math exam, right? You believe it, right? Yeah, this is a calculator, correct? Yeah, you know in primary school, when during math exam, where we all sit down and say, okay, you may begin, and we all take out our abacus. But in primary school, you use calculator? Yeah, yes. Like right now, still use it. Wow. So, are you telling me to identify your friend during exam? I just need to see one girl, right? Oh, Sida. Okay. You want to guess which secondary school I was from? I was in all schools are neighborhood schools. It's all part of neighborhood. I was a school nearby. Starts with an S. You're right, SCGS. Okay, let's move on. Okay, so that we can move on from SGS. Okay, a little bit more. Okay, can I just go to question 10? Question 10. I would like to know which instrument you use. Okay, what do you use to measure the internal diameter of the seat? Okay, who here use the digital caliper? Okay, who use the screw gauge? How do you use the screw gauge to measure the internal diameter? Huh? Oh, you use math. Okay, you notice that the micrometer screw gauge can only clamp things, right? So it's quite impossible to measure things, the internal diameter or something. Okay, why am I bringing this up? So that you use some common sense can during your practical test. It's very weird for you to use the wrong instrument. Could you have measured it using ruler?
Yes.
Technically can, right? Just a bit harder. So the choice of instrument is very important. Next one. External diameter, what do you use? Okay, who use caliper? Who use screw gauge? Actually, screw gauge can or not?
Yeah, but it takes very long to wind up.
Can, right? But as Steven says, you want to use all you have to unscrew very, very long, right? So actually, notice the screw gauge is good for measuring things that are very thin and tiny. So I hope that you use the screw gauge to measure your hair. Who use the ruler? Hey, I think your hair cannot even fill up one division of a ruler. Who use a vernier caliper to measure the hair? I think you will have trouble there to measure. Okay, the interesting thing is the height of the check. What do you use? Yeah, so most of you use ruler. Okay, so for question 10, listen. For question 10, I think the intent of question 10 is just to see if you use the correct instrument. Some instrument, although you can take a measurement, it doesn't make logical sense and it's not convenient for you. Let's go to the last page of your worksheet. We have a quick discussion. So I'd like you to think internally now. Why in the world do we have so many types of instruments just to measure the same thing? For example, length. Right? I'd like you to think that question 1 now by yourself before I call some names. Why do you think we have to use so many instruments just to measure the same thing, like length? Oh, you can write down in point form. You need to write down a full sentence on your worksheet. You can write down in bullet point. Don't need to write a full sentence, just so that we can have a conversation. Question 1. Why? Joshua, you will help, right? Joshua, you will help if you raise your hand first and not clap my sentences. So your question again?
Any other measuring instrument will do.
Okay, question 1. Why bother having so many types of instruments just to measure the same thing? Alright, yeah, I love this class. Okay, yes? We'll go through all of you.
Because
What do you mean by that? Re-elaborate?
because it's like how the digital is what we use to
Okay. Okay, so we may have different types of instruments, all measuring length, but there are many things we can use. No, there are many things that have length, depth, the weight, and all these instruments can help facilitate the different things we want to measure. Yes? Okay, so two things there. Number one, precision. If I want to really be very precise and we want to use something of high precision. Number two, convenience also. If it's not very convenient for you to, let's say, use a ruler to measure the diameter of a test tube, and you have a better tool for it. Yeah? Okay, yes? Sorry? Oh, accurate. Okay. If you use a more precise one, is it? Okay, yeah. The more precise the instrument you use, the more precise your value will be. Yeah? Yes. Okay. Fair enough. If I were to try to use a ruler to measure the thickness of your hair, I can only guesstimate. I'll never get the accurate value. Serious? Up to 3 decimal places of mm. Oh, how long? Oh, that's a good question. Actually, I've not stretched this limit before. I see, okay. So Xavier is also saying that each instrument has their limit to how much we measure. Meter ruler, 1 meter. Vernier caliper up to how much you can widen it. Right? So the size of the object also matters. Sucha?
Because it's better to use a tool than to just look at the object and estimate.
I see, okay. So why have many tools? Because you use your own guesstimate, you're not quite going to get it. Like they asked you to measure the chair, right? Some of you tried to Google the maths. I thought it was very smart. Some of you were trying to estimate by yourself, just hold it up and guess, right? I saw some of you trying to hold your friend up. Okay, your friend is one way, then you go to the chair, then you go up, right? Okay. That was quite cute, lah. Okay. Previous year, I know I had one class, right? So I walked in, then I saw everyone just hugging each other, like going up and down. Okay, the only reason you all exclaim right there, right, is because some of you are very dirty. Everything I say in class, right, is very sanitized. So I'm going to be recorded, right? So, yeah, so you all need to reflect. Think about why you just make so much noise. Okay, go to the next question. They ask you, why must you take note of when choosing a particular measuring instrument to measure? Okay. What must you take note? Okay, what must you take note when you are measuring a particular instrument? What must you take note when you're recording data and measuring? Any precautions you want to take? Yes. And you elaborate? Yeah. Okay. Okay, so it sounds a little bit more like you want to check if your instrument is functional before you start using it. If it's not functional, the readings you're going to get is definitely going to be off. Okay, yes? Okay, what kind of caution? Yeah. Okay, safety. I think that's a very fair point. Actually, all the other instruments you also can play each other one. I even had to scold one boy long time ago. They took the vernier caliper and go and talk the person's name. Yeah? Yes.
You need to write the zeros behind.
Repetition.
Where, what?
Talking about the
Repetition, why? The zeros.
Where?
Why?
Here?
Yes, remember to write the zeros.
Oh, okay. Sorry. I thought Zay is trying to correct me. But Zay is saying when you are recording your data, you must have the correct precision. Thank you for reminding all of us. Samuel? Okay, go. Very anticlimax, huh?
Can I just go and change and then I come back?
No.
No.
Keep going back. Yeah, I must be fair to everyone.
I go back, come back, then I go again, then I change.
You're wasting time.
Well,
Keep
that's
going.
your problem.
Okay.
Yes, that is.
Last question. We asked you what?
What?
Your worksheet are different from your friends. What is the important skills you have to have learned as scientists when you are doing and making science? Okay, as when you were measuring all the things yesterday, you learn anything as a scientist?
Yesterday.
Oh no, previous lesson. You learn anything? Maybe you didn't. Wait a minute. Yes, which one?
Observation.
Okay, observation skills are very important. A lot of the questions here that I'm going to answer is really just to test your observation skills. How many decimal points do you go up to? Can you tell the similarities and difference? Observation skills, very important. Yes. But
Yes, that's true. That's so much inside.
okay, but I have to say, if you want for your primary school learning and your teachers, I won't be able to teach you right now. Because a lot of the things I teach you is because you have basic knowledge. Yeah? So you really must thank your primary school teachers. Yes? So what do you learn? Like this.
Okay, human reaction.
Oh!
Yes,
Okay.
I got
Okay, I like this point brought up. Actually, as humans, you must understand, even as a scientist, you are prone to errors. Okay, you are really prone to errors. Even when you measure, you look from a different angle, it can be wrong already. Okay, so you must understand as humans, you are prone to error. You must be very careful when you use the instrument therefore. Yes? No? Patience. And your patience is very important. Don't rush through when you're measuring. For all you know, the measurement may be fluctuating. One moment you look at it, next moment you look away, it changes already. So wait, be patient. Okay, that concludes an introduction to the instruments. Next time I see you in the lab, we will do a very proper practical that will mimic your practical test. Okay, you will see how a proper practical test will look like. And then I would like you to practice the skills properly. Alright? What we just had was an introduction, you click there, but next time round you must use it properly and measure everything correct precision. Yes? Yeah. Don't worry, if it breaks halfway, raise your hand, teacher will replace for you. Okay, we will never,
And then after the test, the teacher
we will ask you again after. Okay? I mean, we want to make you stress during exam, right? Nothing can break on its own. My dear Xavier, why are you standing there? Okay. Alright. Will you file this worksheet into your print file? Can I get you to open your textbook now? No. Almost time for PE already, yeah? Yeah, I'd like to let you all know, it's not normal for teachers to end lessons earlier so that you can change for PE. That's really not the case. You go up the levels, you go to different classes, this doesn't happen. Usually at PE time, then you go and change as fast as possible. Okay?
But so right, if you use this method basically means you can arrive 5 minutes later after recess, right? Because recess is anything until like 7. So only then you leave. Right? You think that way?
Sure, if you think that way. But I think the logic here is that, who's your teacher? Okay, so is Islam very strict that you must be there at 9 o'clock? Okay, so I do not think Nissan needs you to be there at 9. Okay, so what's the logic here? Have you seen how other classes prepare? Yeah, they have their pens ready underneath. Yeah. So a lot of times they don't even need to go and change. They just on the spot just take out everything and then run over already. Yeah? Okay. Please open your textbook.
Oh my god, is that a bird?
Please find the page in it. Help me. Thank you. Page 55, the one with the shark.
The one with the shark.
As mentioned in our first lesson together from this chapter, that everything comes with a numerical value as well as a unit. Can you hold a bit? Because I'm going to end soon. Yeah? Joshua? Please.
As soon as you shut.
Okay, so everything comes with a numerical value as well as a unit. On page 56, I'd like to introduce to you 7 base units. Yes. Okay. We call these base units SI units. Okay.
Show somewhere, show somewhere.
Are you okay? Okay, don't worry, don't worry. Okay. So we have 7 base SI units that I need you to remember. These units are called SI units. They are standard international units because these are the units that scientists all over the world use. Okay, yeah. But if you go to the US, they use pounds, they use inches. But I can tell you, even the US scientists in the US don't use inches or pounds. They will also use these standard units because we want to have a common language between all scientists. Okay, you and I are learning to be scientists. And the next level that I think we've learned before, if these are the base units, you also have seen derived units. Seen before? Okay, you learned about area?
The last one.
Okay, the last two are ones that we will slowly learn. But I hope the first two you learned in primary school before, area as well as volume. We call these derived units because we are making use of the base units to get these units. To get a meter square, we needed to multiply 2 different lengths. Lengths are base units. To get this, we needed to multiply 3 base units. Length, length, length. Derived units are just derived from the base units.
What is MS?
Okay, what is ms? Meter per second. Okay, what is the negative 1 mean? The negative 1 means divide by. So it's meter per second. You can write it this way or you can write it this way.
So you put a slash when you write a negative.
Alright, if you put the slash, don't need to write negative. If you don't put the slash, you must write the negative. Yeah? Okay, so again, a great question. There's also miles per hour. Okay, but again, miles is not a base unit. It's not the common language scientists use. So this is the common language scientists use for speed. We always use meter per second as far as possible. May I get everyone to write this down in your textbook? It is blank in your textbook
What
right
is
now.
kg?
About what? Say again.
Yard.
Yards, okay. Y-A-R-D, that is not a base unit. That's also something I think Americans tend to use.
What's
Yes.
kg?
Sorry?
Kg. Like what's that?
This is kg per meter cube. So another way to write this is kg meter cube. Okay, this is just another way to write it. Okay, I still see a lot of blanks as I look around the textbooks. Some textbooks not even open. Sorry. If you look at the diameter of Earth, it's very large. Right? If I get you to write this down, it wastes a lot of time. So, scientists have a way to save time. And we use something called prefixes. You have actually used prefixes before. So, for example, meters, right? You actually know of two prefixes. Have you ever heard of kilo? Yeah? That's what a prefix means. Prefix means before the actual unit. What is another prefix you know for meters? C. Where this stands for centi and this stands for kilo. What else you know? You know oh, some of you know micro. Okay, listen up, so on and so forth. Listen. Do you notice that the prefix can be attached to any base unit? I show you an example. Grams. I can also add a K, right? Yeah, kilograms. Oh, nobody really use centigrams, but it's possible. You may have seen milligrams before. Okay, so today, just going to introduce to you all the prefixes, and you can find it in your textbook. Okay? Thank you. Which page is this? Okay, I have good news for you. I expect you to memorize all these symbols. Yeah. Okay. However, just to check, actually I think you all know quite a few of them. Okay, raise your hand if you've heard about this prefix before. Have you heard of pico? Okay, not a lot. What about nano? Okay, you'll find that more and more will know. What about micro? Have you heard of milli? Who has heard of centi? Deci? Who has heard of kilo? Who has heard of mega? Actually, you have heard of mega before. Have you heard of megabyte? Have you heard of gigabyte? Terabyte? Okay, put down your hands. Okay, listen up. So, all of these prefixes, Zen, you have a question? Okay. Okay, listen. All of these prefixes, the purpose of adding them in front of a unit is just to tell you how much bigger or smaller the number actually is. For example, if someone were to say 1 kilometer, we are actually saying that it is actually 1,000 meters, right? What does it mean? It means that when we add kilo, we are saying it is 1,000 times bigger than the number I put here. So, kilo means it's 1,000 times bigger. Mega means it's 1 million times bigger. Giga 1 billion times, tera 1 trillion times. So when you see in your phones that the memory space is 128 gigabyte, it is saying it's 1 billion bytes. Okay? When you see centi, 100, it means that it is 100 times smaller. 1,000 times smaller is what milli is. 1 million times smaller is what micro is. And this is what we expect you to know. Okay, before I release you to change, may I get you to write this down? Oh no, I know all of this is there, but at the end of it you are missing something up. So you are writing. Oh, you don't know like this. Eh? Where you have it printed? Oh, okay, you have it printed. Very good. Can I get you to highlight all the powers? Hey, your math teacher taught you what power is yet? Sorry, you haven't learned it this year in primary school. Joshua, raise your hand when you want to talk. Thank you. Using my phone. Okay, I say again, take out your highlighters. And I get you to highlight all of these powers on that page. Very simple instruction. Some textbooks do not open. Just highlight all the powers. Yeah, powers are all the ones in brackets. Can you highlight all of them? Sarisa, can you go and check on your friend? Okay, the next lesson. Now I understand why some JH1 teachers wear a microphone. Next lesson, I'm going to teach you a very important skill. To be able to convert between prefixes. You see 0.008 meters, you convert to, can you convert to micrometers? Okay, next lesson I'll teach you how to convert. It is math. Okay? Okay, with that, 2 minutes more before your E lesson. Thank you, class.